My name is Ken Peterson. I'm with MasterControl, and today we're going to examine the quality event management process, and more specifically, CAPA. As we think about quality management system and the different components to that, certainly quality event management is one of the most important. As we look at the quality event management system more specifically and break it into its three primary components, we have quality inputs, quality events. We've got a risk-based gateway or filtering system, issue review, and we have the CAPA process, which includes investigations, corrective actions, and a closed-loop methodology to make sure that we solve the problems that we're facing. If we begin with the beginning, good place to start. We have quality events and they begin with inputs. In your organization, they might come forward such as customer complaints, a non-conformance, could be an audit finding, a deviation and out of specification. Essentially, something's gone wrong and we need to find out why that's happening. So in that regard, quality event management is often seen as the post mechanism. It helps us to understand those quality events and do something about them. If we examine these quality events a little bit more precisely, on this chart it's specifically color-coded so that we can get a better feel for how these inputs roll forward. In the yellow, you can see that we've got quality events. Now, those quality events might be represented by a customer complaint or an audit finding, such as we mentioned earlier. And as we look at, for example, we'll take a customer complaint. If that call comes forward, something's gone wrong, perhaps it comes through our call center, telephone response, we can take that quality event and, if possible, the first thing we want to do is resolve that as fast as we can. Now, sometimes we can close the incident immediately through some immediate type of action, and we can then sign off. Other times it's more significant, and it moves into this lighter orange color represented with the decision diamond here, and we move it into a risk-based thinking process, typically done by the quality team or somebody dedicated with that responsibility. The point here is that we're going to look at that and determine whether or not it needs to go into the CAPA process. If we can resolve it with some containment and some effective action, as well as perhaps then tracking and trending it and watching it over a period of time, we might still close the incident. However, many times, because of the significance of that quality event, we move into this darker orange color, which represents the CAPA methodology. And so we initiate the CAPA. And then with that, we would then do the investigation. We would proceed with the action needed to resolve the situation, typically a corrective action, sometimes a preventive action as well. And then we would have our effectivity checks where we would verify and validate that this action indeed does solve the problem. And then we would continue to watch and track this as need be to gain the measurement to give us the assurity that this is resolved. And so thus having a closed loop CAPA process. Now, for those of you that are regulated by the FDA or some of the other notified bodies, you might have heard this term recently. They say 3 loops in 1. What do we mean by a 3 loop in 1 CAPA methodology? Well, you think about the first loop, we could close the quality event in that yellow zone at the complaint level itself. Well, if it moves forward and the quality group deems that we can take this type of action, maybe a containment or a correction, we may close that in the lighter orange color here. Or if it rolls into the CAPA process itself, the darker orange color, we can close it in that loop there. So and thus, you really have 3 loops in one larger quality event management process. To look at that a little bit more precisely, you can see that in that light orange color, there are several steps in order to move through that risk-based thinking or that critical thinking. We'll look at those in a little bit more detail in just a moment. The same in the darker orange color in the actual CAPA process, there are many steps, of which we will look at a couple of those and give you some new ideas on what you might implement in your CAPA process. However, if we think about CAPA and CAPA performance, we're driven certainly towards a solution. That's the whole reason there is a CAPA process. If we look at an open CAPA, rolling into that CAPA process, sometimes we feel like we're in a maze and we don't exactly know what's behind the next corner. Sometimes it catches us and trips us up. Most of us try to work through our CAPAs based on expertise, what we've seen in the past, what knowledge we have, or we bring in a consultant or somebody at work that has some experience with that particular situation, hoping to arrive at a solution. What is required of us, however, is to have a sound methodology or a process. And by process, for our discussion today, we mean that if we do step A and B and C, we'll get to D, and D is a good place every time. In other words, we have a replicable, reliable methodology that's going to take us through a critical thinking process, giving us all the right questions to ask. Now, I may not be able to give you a PhD in asking all the right questions, but as far as CAPA goes, it's not that complicated. If you ask the right questions, you will arrive at an effective solution nearly every single time. So let's look at this process in a little bit more detail, in a little more depth. We call it a closed loop process. You've heard that before, but what is that supposed to do? Primarily, it identifies and resolves problems. It improves our department outputs. It can reduce downtime, scrap, rework. These are good advantages of having a good CAPA process. It should eliminate the complaints and other quality event feeders. And certainly it must comply with the standards given to us by our agencies, such as here in the United States, the FDA, or international standards, or the ISO standards. But bottom line is, it just makes good, sound business sense. And that's the reason we should be doing this. As we look at the specific steps within the closed loop methodology, we're going to talk today about identification. We'll look at prioritization. Death by CAPA is running rampant in organizations today. And without a good risk-based filter, many companies are indeed experiencing death through their CAPA process. We'll look at how to assign and acknowledge the right action and how we deploy that effectively. How to investigate. There are different techniques and tools for investigation. Are you using the right one? Using the wrong one in a place that's inappropriate can cause some significant trouble. And then how to correct the situation, implement those actions, which is oftentimes more difficult than it seems when we look at roles and responsibility and actually getting that accomplished. And then probably the one that's missed most often. Certainly over the last 3-4 years, more 43 observations by the FDA have been written around verification and faulty effectivity checking than anything else. And then do we know how to close it? And do we know how to open it up again if need be? So let's first start with the action, maybe with the end in mind. There's 3 primary actions that are available to us. The first one is a correction, or sometimes called a containment action, or an immediate action. It looks at the immediate situation, and it does something to eliminate the existing condition or nonconformity. It doesn't put it out permanently, but buys us time so that we can operate within the existing objectives and oftentimes move forward into looking for a more effective corrective action. Corrective action is different than the preventive action in that the 2 key words we want to focus on here in the chart you can see are reoccurrence and occurrence. A corrective action eliminates the root cause. Therefore, if I eliminate the root cause, I'm keeping the problem from ever occurring again. If I look at occurrence, I'm trying to get out in front of something that may happen. So therefore, I'm trying to block a potential problem. And we call that a preventive action. So important to remember, corrective action, elimination of the cause, where preventive action is identification and elimination of the potential cause. Now, let's go ahead and apply that then to some of these stages through the CAPA process. First, let's look at CAPA and issue review. So issue review would have been that lighter orange color, wherein organizations struggle with having a good gateway by where they can manage risk and do something. So we're going to look at defining the origin of the concern, that quality event that feeded to the issue review. We'll look at an outline that gives us some specifics of the quality event. How do we define it well enough to move it into a risk-based decision process? We'll definitely look at and determine risk. We're going to do it in two different elements. We'll look at impact, and we'll also look at frequency of the quality event. That will help us make a decision. And then we'll determine the next level of action required, or how we disposition this, whether we do it immediately with a correction or a containment action, or do we send it on for a corrective action and very possibly a preventive action as well into the CAPA process. Here you can see what kinds of quality events we might expect. Well, as we mentioned earlier, we could have a complaint, we could have an out of specification, we could have a failed audit finding. No matter what that event is, we bring it into this issue review critical thinking methodology. On the slide, you've got a worksheet that will give you some of the key components to examine to aid in your critical thinking. The first one is to take that quality event and just pull it forward. If we were using this worksheet, we would write that down up at the very top. Oftentimes, friends, as this cloud represents, it comes to us in vague, cloudy, nebulous terms. Now, I'm not saying that the folks that took the complaint, for example, didn't ask a few good questions. Perhaps they did. But it's really not their area of expertise to gather up the information needed so that we can use a risk-based filter and make a decision whether or not it feeds to the CAPA methodology. And so we get sometimes some fuzzy information. And that's what that middle stage here on this worksheet represents. You've got to get some specifics. Now we're going to gather specifics using some key questions around some W's. Let me explain. Here you can see a little bit better what those W's are. Those are going to be represented by what, where, when, weight, and who. So 5 W's. Now, weight doesn't stand for how many pounds you weigh. That's the magnitude. That's the impact of that quality event. And it's kind of like this bullseye activity here. Let me demonstrate. Up at the top you can see striking out at the outer rung, and down at the bottom hitting the mark precisely, or the bullseye. And as I ask questions, I'm trying to get the most precise piece of information to aid me in my decision-making process. An example might be to ask a question such as, I'll pick the where category, and I'll do something that's a little off to make my point. But where did you go on vacation? Well, somebody might say, well, we went to Hawaii. Well, where in Hawaii? We went to Maui. Well, where in Maui? Well, we went to the Holiday Inn on the beach. Well, where in the Holiday Inn did you stay? Well, we stayed in room 212. Well, where in room 212 were you most of the time? Well, I was on the sofa. Well, where were you on the sofa? Were you on the left side or the right side? So what I'm doing is I'm gathering more precise information to write down as my input. I can do that with each one of these dimensions. I could certainly do it with who or with weight. I remember recently a situation where I was in a hospital where we'd had quite a significant quality event, and I was working with a group of pulmonary doctors and an infectious disease doctor. And when I asked who experienced this particular problem, the infectious disease doctor said, well, just about all the physicians here in San Pedro General experience this problem. And I thought to myself, you're kidding. That's about 2,000 doctors. That can't be so. And so I said, could you be more precise? Give me the names of who actually experienced this problem. And he was able to come up with 4 names. And then once I got those names, I'd say, and of those 4 names, each one of them had a patient that they experienced this problem with. And that then went down to 1 pulmonary doctor and the infectious disease doctor that experienced the problem. So we went from 2,000 to 2. Quite a reduction. And that's what we're trying to get with these W's, is some specific information. Now, once I've got specific information in terms of what precisely happened, where it happened, when it happened, and don't just tell me last month, I want to know the date, the time, the weight of the problem, what was the impact, what was the consequence of the situation, and who experienced it, I'm then able to go forward and do some risk-based thinking. Every good organization should have a gateway in their CAPA process. And the reason for that is that it helps to eliminate death by CAPA. We can't allow a big myriad of inputs to flow into the CAPA process. we have to work on the most significant situations. And then with those significant issues, we'll solve those through corrective action. But many of the others that are not as significant, we will contain those and solve those through containment, and we'll monitor them until they become significant. And so the two things we're going to look at here in this gateway is impact, or severity, and we'll look at frequency, or how often has this occurred. These two elements will give us some great information in determining risk. Now, the guidelines that we must follow are that we have to assess each issue for impact and frequency. It has to be done on a one-to-one basis. We'll be specific with those W's in our assessment, and if you don't have specific information, you will find it near impossible to score the quality event for impact and frequency. Then we'll determine what our path forward is going to be, and if need be, we will register it into the CAPA process, we'll follow the methodology, and then we'll determine what that corrective response is going to be to eliminate the situation. Let's take a look at the gateway score here. Sometimes frequency is measured in different ways. We can do that specifically to our organization, but as a general guide to get us started, we're going to pull from the standards that are given us, and we're going to use a simple 4-stage scale. Now, whether you use a 3-stage or a 4-stage or a 5-stage, that's entirely up to your executive team, but this will give us a good place to start. MasterControl oftentimes consults with organizations to help them determine what is the best scale for going forward. Here you can see a scale from rarely to continually. Now, rarely, unlikely to occur again, and continually, the definition being occurring continually or constantly. Now, we could quantify this as well if that's something that's desired, but we're going to work for sake of this short lesson using qualitative terms. If we look at impact, our 4-stage scale starts with negligible, and it will carry forward to critical. Negligible, there's no risk of injury to the patient and or user, operator. And critical, the problem resulted in a serious injury or death to the patient and or operator. And then minor and important are the two factors in between that you can see on our 4 stages here. If we look at that now and put that into a scoring matrix, we've got frequency over on the left axis and we've got impact up above. And we can see that we've got numbers to indicate 1, 2, 3, 5 up the frequency scale, and we've got 1, 3, 5, 10 across the impact scale. Now, those of you that are sharp, or perhaps had some statistical background, you can see that this is definitely skewed. We've skewed the impact side over the frequency side. Why? Why would we want to do that? Well, certainly those that regulate us are interested in the safety and the well-being of those that use our product or our service. And so impact is skewed towards safety. And as we look at the colors, the green, yellow, and red, we've set those colors such that down here at the bottom you can see if something scores out, a quality event scores out, in the green zone, that's going to be determined as acceptable. We're not really going to need to advance that into the CAPA process. In other words, we should have resolved that in that first loop. We should have resolved that at the complaint level. Why did that even go forward to the quality team to evaluate it? And this is part of the ongoing education that will need to go into a good CAPA training system for your organization. Now, if that went to yellow, however, that then has need to be evaluated by the quality team or by somebody assigned to look at these inputs. Yellow then means it's an undesirable situation, and at a minimum it's going to require containment, and it's going to require a watching process, or it's going to have to be measured and monitored over a period of time to make sure that the containment that we took either brings it back towards green, or if it slips up to red, that we move into a more aggressive posture. If it goes into red, friends, you have no choice. That means it must go into that third loop, the CAPA process, for examination. And a corrective response is going to be required. Now, here you can see a corrective response, once again, is an action that eliminates this quality event permanently. And that's what we would be charging after with a red type of situation. So as a recap, through this lighter orange color, what we've had is a quality event that's gone through loop 1. We didn't resolve it at the call center. It's moved into somebody else to look at. And now what we've done is we've taken it through a risk-based filter, and we've determined, for sake of our example here, that it's in the red, and we're going to move it forward into the CAPA process. Now, if it was not, and we wanted to close it there and just track and trend it, that would be culmination of loop 2 and well within our right. However, for sake of our education, we'll take it into this darker orange color. Now, up at the top of this chart, you see something very important that I rarely see when I'm out working in a consultative effort with our prospects and clients. And that is that there is a diamond here after this is escalated to the CAPA process. And that diamond asks us to determine essentially if the cause is unknown or the cause is known. If we've seen this before and we are very convinced that we know the cause, we can move quickly down through into that corrective response. Now, the whole idea of a good CAPA methodology is not only to get it right, to be effective, but also to move quick, to be efficient. And so we want to have both an efficient and effective process. A good goal to start with is, are we moving our quality events through about twice as fast as we used to? That should be a good goal to accomplish over the 6 to 12 month period of the initial deployment. Now, if we don't know the cause, obviously we need to go into an investigation. And for sake of discussion here, we're going to talk a little bit about investigation, an area that gives people a lot of difficulty, particularly if you think back to where we started. Do you resolve your issues based on expertise, or do you base them on good questions, critical thinking, and a sound process? Our agency requires us to move this through a better process. Now, whether the problem or the quality event comes as an internal system issue, it could be something wrong with our equipment if we manufacture equipment and send it out for others to use. It could be product related or service related. That's not important. A good process should work for any of these types of quality events. And if the cause is unknown, we need to understand the cause before we can take any action. To take action without knowing the cause may be an educated guess, or it could be a catastrophic failure as a result of that guess. So, to give you a sense of the 3 different approaches to problem solving, I'm going to go back to kind of a bullseye type of example. And to do this effectively, I'd like to share an example with this light bulb. Everybody can think about a situation where perhaps you've arrived at a room in your house. I'm going to select the entry to my home, where I arrived and I went to hit the light switch, and folks, the lights didn't come on. Now, I stood there in the entry kind of scratching my head thinking, geez, what's going on here? I'm not sure. You know, they came on yesterday, they worked just fine, but right now I'm standing in the dark and the lights aren't coming on. Now, we could all go through and say, well, what would we do about that? What might we think we could do to resolve this situation? Some people might say, it's not that important. I'd rather just get inside the house. It's raining outside. I'm just going to go right through this problem, enter in the house, and just forget about it. Others might say, gee, you know, I could walk down to the circuit breaker box, open up the panel, and see if maybe I've tripped something. Others might think to look across the street and see if the neighbor's lights are on. Another response might be to change the light bulb. I'll just put a new light bulb in here. This thing is going out constantly on me. My past tells me it's probably the light bulb. And with these kinds of responses, we can see the types of problem solving or the type of investigation that many organizations follow. Now, this is important because not only do people make the mistake of selecting the wrong process at the wrong moment, but it can also have consequences that unforeseen can cause problems in terms of budgets, in terms of time, in terms of getting the response into the right place for evaluation. And I'm going to label these 3. First, trial and error. Second, we'll call one expert or experiential thinking. And then the last one, comparative. Let me give you an example. If I took that light bulb and I replaced it, that would be an example of trial and error. Now, that might solve the problem. Then again, it might not. I really don't know until I do what? Try it out. Now, there's some positives to that. I could get the right answer quickly. It could be fast. But what are some of the negatives to that? It's reactive. I could be wrong, and I could start to add complexity to my problem. I also might introduce risks depending on how I'm tinkering and playing with this and how it affects other things upstream or downstream in the process. So using trial and error, while maybe effective many years ago, is tended to be frowned upon today as a problem-solving methodology. The next one is the expert approach. Now, for example, if I walk down in my house, in the basement is where I find the power panel. And if I open up that door, I can see there that perhaps I've got a breaker that's been tripped. And I could see if it correlates with my entry. Maybe my contractor's been nice enough to label that for me. And I can put that back on and see if that resolves the problem. Now I'm starting to get some information. However, it supposes that one, I have enough expertise to find that panel, that I have a little bit of electrical background to think about the connection between this circuit and what's going on in my home circuits. And so I'm starting to use past history, perhaps even, maybe this is tripped before. I'm using some experience to solve the problem. Now that's better, but what happens if, for example, here I stand, and this is my tunnel, my expertise, my thinking, but the cause to the problem is over here. Well, I've got a problem because it's outside my expertise. Now, I could go bring in a consultant. Maybe I could get somebody else to see over there. But the problem with that is it slows me down. It's expensive. It could be disruptive. I could have customer dissatisfaction. I could have a lot of unwanted effects as a result of relying solely on my expertise. We did learn, in fact, I used to teach class after class at the university to my engineering students, classes on things such as fishboning and other kinds of effective statistical techniques, where we did modified brainstorming of such. And we took that data and we organized it using our expertise to try and find root cause. Does it work? Yes, it can, but it's limited in its scope. So the third situation, comparative. Now you might recall I said, perhaps I look across the street. I'm going to tighten that up a little bit and say that I walked into the house, the lights don't work in the entry, but as I turned them on in the kitchen, they came on and they worked just fine. What do I know about my problem now that I didn't know when I first started? Well, I began to isolate it. I could logically expect to see the problem in the kitchen too, but I don't. So I also know what the problem could have been, but it is not. So I'm opening up a set of data that is going to allow me to think deductively. And with this new data, I can then start to look for clues. What's unique? What sets apart the entry from the kitchen? Well, don't tell me nothing, because yesterday it worked in the entry and it still works in the kitchen. Something's different, something's unique, something's going on between these sets of data that's going to account for what the root cause is. So if we can teach people to ask better questions in these W's, if they've started to establish some of that information, now we can gather up some investigatory data, as it shows here in the 5-step process that we use most often today. The investigate would come after the problem statement, and it would be what we term the is information. So sometimes this is referred to is not thinking. But the is thinking would be, what is happening? Where is it happening? When is it happening? And the comparative information then would be, when could I logically have expected this to occur? But it was fine. Where else could I go to see this problem, but it works just great? And then within that, that can help me with a clue, such that that clue can help establish what might be causing this problem to go wrong. Now I want to talk a little bit more about these is not comparisons. On this chart that you can see called up, you'll notice that the first piece in red is the problem statement. Now the problem statement should carry forward through all three of the loops. When I filed the complaint, I got a problem statement. It may have been a little loose, may have been a little fuzzy. It got a little tighter as it went into the issue review process. As it tightened up, it's going to tighten up even more if I send it into the CAPA process, where I should be able to state that problem state with some specificity. Now, as I go down through here, you can see over to the left, what I've got is the what and some key questions here that I'd like to expose you to that you might consider asking when you do an investigation. For example, if I look at where do I have to physically go to see the problem? Where on this particular medical device is the problem occurring? And then next to that, I've got some is not. Now, let me give you an example. Just a couple of months back, I was called in to work with a very simple device I think we can all relate to. I get in trouble because I call it a scraper, but it's a scaler, and the company that makes these dental instruments, what was happening is if you visualize a scaler, it's kind of curved on this end, and then the dentist holds it on this end, or the hygienist, and then it's kind of sharp and pointy and curved down on the bottom. And they rotate that and flip it in their hand constantly as they pull the plaque off of your teeth. Now, the tip, about a 1/16 inch of the tip of that scaler, when the pressure was applied to it while it was inside the patient's mouth, would pop and it would break off. And on average, it would lodge itself about 1/8 of an inch deep in the patient's throat. Now, that's not good. We call that a deviation. We call that a quality event. And it came back to that organization in a number of complaints because it occurred many more times than just one time out in the field over a period of a couple of weeks. And so we logged that into the process. Well, what I'm trying to point out is not only was that a complaint, but it went into the issue review process, and because medical intervention was required, dentist isn't going to pull that out of your throat. He's going to send you on to a doctor. And because you had to go to a doctor, it then rated into the red zone, and because of the frequency, it was significant. In fact, they were looking at a recall. And so as we gathered up the information, it got interesting. It got fascinating. When I first got there, I said, well, for example, I'm just going to look at one of the W dimensions. Where do I go to see this? And they said, well, obviously at the dentist's office. Well, where are those dentist offices? And we found that it was only occurring in the region that encompassed the Arizona, Utah, and Colorado states. We found that it could have been occurring in California. It could have been occurring in Idaho. We sent the same product to those states, but no, it wasn't occurring there, only in these states. I thought to myself, well, unless it's a little hillbilly dentist, they're going to have more than one chair in those offices. And we found that it would only occur in one chair. We might have 3 chairs. It would only occur in one of the 3 chairs. Could it occur in the other 2? Yes, but it never would. And then we started to move over to these clues. We would say, well, what's unique about this chair versus these other 2? And the dentist told me, said, nothing. There's nothing. Nothing's different between this chair and this chair. And my response to the dentist was, no, I'm sorry, I just can't accept that information. You're wrong. Otherwise, it would be occurring in these chairs too because you use the instrument in all 3 chairs. So it has to occur in all 3. No, I've got my data right. It only occurs in one. And so we now started to go into our critical thinking based on the data sets that we were establishing so we could say why. Why this and not that? What's the clue? What's different? What's distinct? What stands out between this chair and this chair? And we started to get some very interesting information. For example, the person that used that chair where it occurred, in all of the instances, and that's more than 50 instances in 50 different offices, could only be left-handed. And so I would ask them, what's unique about a lefty? And they said, nothing. A lefty's the same as a righty. Doesn't make any difference. I said, wrong answer. Otherwise, it would be occurring with the righties too. Oh my gosh, you're right. Well, I can't think of anything unique about a lefty. My point being, as we moved through the investigation, we began to get information to explain what was unique about the problem versus the comparison. And with that information, we could fill out our investigation form and arrive then at some conclusions as to what might be causing the problem. Now, what causes are suggested by these clues is where we're trying to move the critical thinking these days. So as you can see here in this simple chart, we started with a problem statement and we went through some critical thinking, and now we've arrived at some likely causes. Now, there are several steps that I am rushing by and leaving out, but I want to slow down and share this last one with you. This step occurs well ahead of the effectivity checking or the validation. It's a logic testing step, and it can save you an immense amount of time in your CAPA process. And that is that once I've gathered my causes and I've gathered that data, why not go back and ask the simple question? If this is my likely cause, will it explain why I've got this set of facts and not this fact? In other words, if this is my likely cause, will it explain why it only occurs with left-handed dentists and never with the right-handed dentist? If this is the likely cause, will it explain why it only occurs on the top of that scalar, but never on the bottom? If this is a likely cause, will it explain why it is on side A and never on side B? If this is a likely cause, will it explain why it occurred 3 days ago and we've manufactured this for 4 years and it never occurred in the previous 4 years? It must explain that data, and if it doesn't, you do not have the right cause. You have no business moving forward into spending your organization's money in an invalidation or an effectivity checking process and the company's time in order to think that you can verify this only to find out that you were wrong. So there are many steps now in the CAPA process that we need to use a little bit better, such as good logic testing. Well, our time is up for this lesson. I hope that it's been informative and you've got a sense of some of the elements that go into quality event management and the new CAPA thinking. But before we close, let me recap. Here you can see in our chart, we started with the yellow, and that was our feeders. Those were the quality events. It could have been a complaint, such as this scalar incident we talked about. That was the first loop. If we can't resolve it there quickly, and it escalates into the second loop, into the issue review process, somebody that understands things from a quality perspective with a little bit more responsibility from that part of the organization looks at it and determines whether we're going to contain it with a precise containment action, or are we going to send it on into CAPA. And we called that a risk-based filtering process for CAPA. Do you have a risk-based filter process? If you don't, and you're experiencing death by CAPA because of a myriad of inputs, you need to rethink your process. Now, if it moves into this darker orange color, and we move it into our critical thinking, our investigation process, certainly one of those steps is investigation. But following the investigation come many others. In future sessions, we'll be looking at effectivity checking, and we'll be looking at our corrective and preventive actions and how to deploy them effectively. We hope you'll join us and understand those and deploy some of those sound concepts in your organization. But as we wrap out of this, the last step is to make sure that that action is indeed successful, that the management approvals are in place, and we have a closed-loop methodology that allows for effective dispositioning, and that those dispositions improve our business, they improve our quality systems, they allow us to be more successful as an organization, and ultimately have a safer and better product in the marketplace. Thank you very much for listening.